Hello everyone, my name is Nick. Just making this video to go over something that's pretty important in networking. That's going to be default gateways. The reason default gateways are important is so that your computer knows how to talk to computers on different LANs. So these are going to be two separate local area networks, the blue side and the pink side. One's for Bob's PC, one's for Alice's PC. Now, if these were on the same local area network like this, we wouldn't have to worry about setting up a default gateway for them to talk. They could just talk, which I can show you that here in a minute. But since they're on different local area networks, we're going to need a default gateway. So Bob's computer is going to have to know where to send packets that are destined for a network other than his. Same thing goes for Alice. She needs to know where to send packets that are destined for networks other than hers. So if she wants to send a packet to Bob's network, she's going to have a default gateway. Now, the default gateway is what we're going to set on the router's interfaces. So this G00 interface is going to have Bob's gateway, and this G01 interface is going to have Alice's gateway. Let me show you what I meant by having another computer on the same LAN. They don't need a default gateway at all. So we'll set up this PC1 here. Let's also give Bob's computer and Alice's computer an IP address. We're going to make sure we put it in this address range. We'll give him 192.168.1.5. And the subnet mask autofills for us, which is correct. The subnet mask is pretty much what tells the computer what network it's on. You also need these on router interfaces just so that it knows what network it's on. Which that's a whole nother topic that will have to be discussed in a different video. So we gave him an address. Let's go give Alice an address. We'll make sure hers is in her network range. 192.168.2.5. Keep it simple. So another thing about the subnet mask, each octet can range anywhere from 0 to 255. Whenever they're at 255, 255, 255, that's pretty much stating that this is the network address. So if we put a 0 here, which is just like this, that's showing that that's the network address. Of course, you can't use 0 and you can't use 255 because they have other uses. So it has to be within the range of 1 to 254. But we'll just give her 5. And PC1. Let's give this guy an address. We'll keep it within the local area network address range. We'll give him a .6. Alright, so if you're following along, go ahead and open up simulation mode. Just so we can see this packet actually traverse the network. It's really useful, especially whenever you're troubleshooting something's not working. You can just open up simulation mode, see where it's stopping. So let's go ahead and ping Bob's PC. This will send an ICMP request, which you'll have to hit show all none to clear all the filters out, and then go to IPv4 ICMP. Now we'll ping Bob's PC. And this should work because we don't need a default gateway. We didn't set a default gateway on Bob's computer on PC1. This interface is down right now, so it has no address on it. But since they're on the same local area network, we don't need a default gateway. A switch's job is to forward frames, forward packets out of every port except for the one that it comes in on. So the switch should get this packet, send it down to Bob's PC. Bob's PC will be like, oh yeah, that's my address, so that packet's for me. And then it'll send a reply back. So now you can see this ICMP request. Switch gets it. The switch has something called a MAC address table, also called a CAM table. And CAM stands for content addressable memory, I think. Pretty much every computer has a burnt in MAC address. And whenever we sent this, it logs in its CAM table that the MAC address for PC1 is going out of port FA0/2. Now that's on a 300-second timer, a 5-minute timer. So it'll forget it over time, but it'll keep the entry in there if you keep sending packets across the network. So, and then the switch will forward that out of every other port, which the only one is F01. Bob's PC is going to say, yep, that's for me, and send it back. And they'll go through this for 4 times. And that is your ping. So that's the nice thing about simulation mode. You can also go in here. Oops. You can do a show MAC address table. And just like that, you see on port FA02, which is fast Ethernet 02, we have the MAC address of PC1. Out of port fast Ethernet 01, we have the MAC address for Bob's computer. So we don't need a default gateway. If they're on the same local area network, you don't need that. But it's not often that we're sending things in the same network within the same LAN. That's why we need a default gateway. We need to be able to talk to Alice. So we'll go in here and we will set the default gateway. Do an enable, configure terminal, conft, and we'll start with Bob's side, Bob's LAN. It's on gig 00, so we can just go interface G0/0. Now we're going to add the default gateway here. And we're adding it on this interface for the same reason I said earlier. It's the one that's connected to Bob's computer. It's the one that's connected to Bob's LAN. The default gateway address can be anything in this range. We're just going to make it 1. So 192.168.1.1 just to keep it easy. Some people use the last address, like it would be 192.168.1.254. It's totally up to you. We're just going to leave it as 1 because it's easier that way. So we'll use the command IP address. This will add the IP address to the interface. And we can't forget the subnet mask. All right, that looks good. And we got to make sure we put the subnet mask here. That way the router knows that this is the address of that LAN, or the network address. The .1 with the network address is the default gateway. That's what we're applying to the interface. So once we do that, we should be good. Well, these triangles are still red. And that's because we need to bring the interface up. We do a do show IP interface brief. We can see gig00 has an IP address, but it's administratively down. So we just need to bring it up. It's pretty easy. All you have to do is one command. It's no shutdown. And as you can see, as soon as we did that, the state changed to up and the line protocol changed to up. So as I said in a previous video, the state's going to be the physical layer, so that layer 1, and the line protocol is going to be the network layer. And as you can see here, we got a green arrow here in the up direction. We're just waiting on the switch, and there it goes. So we should be good. We have the default gateway there. Now let's do the same thing for Alice's side. Exit, interface, interface G0/1. So we're gonna make her IP address her default gateway for this LAN, pink LAN. It's gonna be the same as Bob's with a .1 at the end, but it's a different network, which is why we need the default gateway, 192.168.2.1, and the subnet mask so that the router knows what the network address is. It would be this, 192.168.2.0. Yeah, that should be good. And once again, we have to bring up the interface. So we'll do a no shutdown. And we got a green arrow here. We're waiting on the switch. Now the reason it's in the orange state right now and it's trying to come up is because it's in a listening state. You'll learn more about that whenever you get into spanning tree protocol. It's really interesting, really confusing, but once it's done being in the listening state, it will go into another state. There it goes. All right, so we're good. We have our default gateways set. All right, and if you're still wondering, why do we need default gateways? Why does the computer need to know about it? Why does the switch need to know about it? Because they have to know about it too for some circumstances. Just try to think of it like this. If you're going to send a letter to Alice, Bob wants to send a letter to Alice. Bob only needs to know where his mailbox is. His mailbox is gig00. So Bob wants to send a message to Alice. He takes the message and puts it in the mailbox. The router does the rest. The router's job is to route, just like the post office's job is to figure out where the letter is to go. So the post office does its job, sticks that letter in Alice's mailbox, and Alice is able to get it. Another way to see that is you can do a show IP route, and you can see that There's some directly connected networks, and that would be here. So out of gig 0, 0, it shows the default gateway, which is right here. So anything that is sent from Alice to Bob, the router knows to send it out of this network because, out of this interface, because this network is attached to this interface. Same thing goes for Bob sending something to Alice. Whenever it gets a packet for Alice's network, it knows that her network is attached to this interface, so it knows where to send it out. Once it gets to the switch forwards it. Alice says, oh, that's from me, and that's the end of it. All right, so now we need to make sure Alice and Bob know where their mailbox is. So we'll add their default gateway here. We'll add Alice's. And these are the same addresses that we set on the interface up here. All we're doing by putting them in the computer is telling Bob's computer where their mailbox is, where to send packets that aren't destined for their network. If Bob was just sending to PC1, it doesn't need to know that. It would get to the switch, it would forward it. The router would say, oh, that's for this network, so it's not for me, I'm going to drop it. And the switch would forward it to PC1, and PC1 would be like, oh, that's for me. So we'll close this. And now we should be able to ping Alice's PC. Let's just go ahead and do this in simulation mode. That way we can watch everything happen, just because it's way more fun like that. So we can do a ping 192.168.2.5. That's Alice's computer. We'll hit enter there. Let's minimize this. All right, so there's the ICMP packet. So it's going to go to the switch. Switch is going to forward it everywhere. It's set for out of its ingress port. So it's set for the port that it receives it on, that F01. It's connected to Bob's computer. It won't forward it out of that one. So that first one that failed, let's see if it lets me add a filter. That's something that will be discussed in another video. It's not letting me, oh yeah, there it is. So it's the address resolution protocol. So we had to figure out what MAC address was connected to Alice's IP address. So pretty much Alice is saying, yep, that's for me. I'm down here. That's my address. And R1 knows that it can send that packet over here. If Alice was to have a different address than the one that was in the ICMP packet, the 192.168.2.5, if Alice had .6, then that ARP request wouldn't have got a reply, and the packets would have dropped. It would have had no reason to send that down there because there's no address down there, or there's not that destination address isn't in this LAN. So let's go ahead and click forward. So this is I kind of went back. This is the ARP request from Bob's PC. PC1 says that's not my address. I'm just going to drop this. And then ICMP starts, packet gets delivered to R1. R1 has to send the ARP request to figure out that Alice is down there. Alice says, yep, that's me, I'll send something back. And then the ICMP request can go all the way through to Alice. So this is the ping that we sent to Alice. It went from our network at Bob's PC to Alice's network at Alice's PC. See if we can see this here. So that first one that timed out, you'll get this a lot, is pretty much the ARP request. Alice sends it back. R1 knows where to send it. And it goes back and forth. All right, so now our networks can talk, which is what we wanted. That was the whole goal. We'll go back into real-time mode. Now, if you're thinking like I did when I first started, I put the default gateway on the router in the right spot. Why do I need to put it in the computer too? It's just so that that computer knows where to send packets. It has to know where its mailbox is so that it can send a letter to Alice. I can show you this real quick. Hop back into simulation mode. I don't think we put a default gateway on this computer. We didn't. So let's ping it. Alice has a default gateway. She knows where to send packets whenever they're destined for this network. So, which is her default gateway, her mailbox. So let's send a packet over to PC1. Let's see what happens. So right here, the ICMP stopped. That's where you get the request timeout. This green packet is going to be the ARP. So since earlier we only pinged from Bob's PC to Alice's PC, the ARP table in the router knows where those addresses are. But this is a totally new address. So it's got to do the ARP process again, but for a different address. So it'll send the ARP request down. Switch doesn't have that address in its MAC address table, its CAM table. So it forwards it out of all ports, except for the ingress. PC1 sends it back. Says, yep, that's me. And now the next ICMP message can go through and hopefully not fail. But remember, we didn't set the default gateway in PC1. It doesn't know where to send it. It has no idea where its mailbox is. It doesn't know if it's at the back of the house, at the front of the house, or if it's in some PO box down the road. It doesn't know. So it can't reply. It can only get the ICMP packets. It's going to happen again and again. So that's why we need a default gateway. That's why it's important. To fix this, all we have to do is go in here and add a default gateway. It'll be the same as Bob's. They use the same mailbox. They're in the same apartment. Now that that's set, we can go up here. PC1 has to do an ARP request too, so that it knows where the default gateway is, what that address, what MAC address is attached to that IP address, and now it can send them back. Alright, so that's going to be it that I cover in this video. It's kind of stretched a little long, but this is a super important topic. Having a default gateway is how you have networks. It's how networks talk. It's super important, so I hope everyone followed along and has a better understanding of default gateways and why we need them. If you're a little confused about the address resolution protocol part of it, all those ARP packets that were being sent, then just watch my other video on ARP and hopefully you'll get a better understanding of that too. Thank you for watching.